When researchers set out to study what ram tough means, they were thinking this. Horns, antlers, seashells, toucan beaks are just some of the amazing wonders of nature being scrutinized by these scientists and their research team at the University of California, San Diego.
What do you think these are?
What is that?
I don't know.
Their research also takes them to the Scripps Institute of Oceanography nearby, where some of the natural wonders reside, including the tough little abalone shell that started it all.
About 10 years ago, I was involved in a project for the Army where we were developing armor. And the idea came that the abalone is made out of chalk or chalk-like material, calcium carbonate. And although chalk is very weak, this is thousands of times stronger than chalk. And you can try to break it, you cannot succeed, you see.
For simple material like chalk to be structured into such an indestructible object left scientists Marc and Joanna wanting to know more about how shells and other objects in nature are designed. For example, how can ram horns and elk antlers withstand such impact without breaking apart? And who knew horns were so different from antlers?
The first thing we do is we cut it and look at the cross-section, and that's how we identify what's known as the microstructure of the material.
Using this state-of-the-art scanning electron microscope purchased with support from the National Science Foundation, scientists are seeing details they've never seen before. The antler and other materials can be magnified as much as 50,000 times.
And what's surprising about the elk antler is it's really a bone.
They're learning that the antler has a porous, bony center surrounded by a sturdier, denser outer shell, evolved over millions of years to do one thing: to fight.
It doesn't serve any structural purpose like our bones serve a structural purpose. They create bone marrow, they're calcium reserves. But in antler, they're just used for fighting, so they have to be very robust.
The same can be said about horns, but they are different than antlers. Horns are hollow and made essentially of keratin, the same stuff found in our fingernails and hair. And here in the lab, just like with the antlers, horn samples are tested for endurance and strength.
This is a ram horn sample.
Undergraduate Brandon Reynante built his own version of a crash test simulator.
The machine is designed to simulate rams butting heads during fighting. Once we have the machine all set up, we just press the button to drop this impactor right here.
How can these hollow horns withstand such impacts? McKittrick says it has something to do with microscopic air pockets or tubules running lengthwise that help horns withstand intense forces.
You can't see the tubules, they're nanoscopic. Okay. Yeah, they're through here.
There's no end to what they find to study.
These are the teeth of a Komodo dragon. Here you can see the serrations, the tiny serrations along these teeth.
Then there's the toucan. Its beak is 1/3 the size of its entire body. You'd think it would be too beak heavy to fly, but the beak weighs almost nothing.
And it has a structure that is absolutely fantastic. The inside is almost hollow, but it has a foam, and the outside has a shell, and it is extremely strong.
So why bother knowing all this? Just think gecko. Examining and magnifying the gecko's uncanny ability to stick to surfaces led to the creation of new surgical tape. Studying horns and antlers could lead to any number of new energy-resistant man-made materials like bumpers and helmets. Knowing the structure of rugged shells of the armadillo and tortoise could help develop better protective gear for the military. Keying in on the sharp details of sharks or Komodo dragons' serrated teeth could lead to better cutting tools. And that lightweight toucan beak could lead to man-made materials that one day lighten the load for boats, planes, and automobiles.
We need to decrease the weight of our transportation systems to enhance efficiency.
For Science Nation, I'm Bruce Burkhardt.